Hey, welcome to the last week of the LabView class. In today's week, we're going to talk about image processing. It's basically some introduction to image processing. Depending on the applications of your project, you might find it useful, or you might need to explore more to understand more for your project. Uh, there is some extensions of LabVIEW that you basically have to pay for them to do image processing. So the normal LabVIEW software that we have in CCIT department that you already all installed in your laptop or your computer, it cannot do the image processing for you. You have to pay, I guess I asked them once, you have to pay around $5,000 to have the add-ins the add-ons that can actually do the image processing for you. One is I think one $2,000 for just pay for an app part of it that you can import images, something like that, and then another $2,000 for image processing the data. But for in my project, I had to do some image processing, and I had no money. Like I didn't have like $5,000 to do the image processing. So we all know that MATLAB can do image processing to some extent, and it's really useful. So I was like exploring more in the internet and checking LabVIEW and MATLAB, and I realized that LabVIEW can actually communicate with MATLAB with a function called MathScript. I guess in the next video, I will show you how this communication works. So yeah, LabVIEW can do that, and so if you can write a program in MATLAB and build a function in MATLAB that can do the image processing, then you can link MATLAB with LabVIEW, and then MATLAB will run on the background of the LabVIEW and do the image processing for you. So for example, for my application, I had a tank that was filled to some extent with some dark liquid solution, and I want to know the water level in that solution in that reactor. And then for that, I thought that image processing was really useful because I could use some like colors that are really distinguished, like red and green and black, and then I can differentiate what is the that dark liquid level in my reactor. And I use the MATLAB. I wrote a code for it, and then I linked MATLAB with LabVIEW. And while I was running LabVIEW in my project for some other analysis, I could run this image processing at the same time too, because I have some pump that are feeding the reactor, and I didn't want a water level to exceed a certain level. So I need to send signals to pump to say either stop or run faster or just run normally. And I could only see that based on the water level of the of my reactor, and I could do that with image processing. I will show you all in the next video, but in today's video I'm just gonna talk about how to do some this kind of like image processing in MATLAB and show you the add-ons that the MATLAB has for image processing. So without further ado, let's get started. So here I have a paper and a keychain that is like red. So a white paper and a red keychain. And I want to take a picture of that, and I want to keep the red keychain and change the background to black. So whenever you take a picture of with your camera, you in MATLAB gets a matrix that has an X and a Y, which is basically the pixel points of your image, and another dimension which has three levels. So basically, you will have three matrices: the front matrix, the middle matrix, and the back matrix. And these three matrices are the red, green, and blue matrix. So basically any color is a mixture of the red, green, and blue. If you give numbers to the red, green, and blue, you can create a different color. For example, black is 0, 0, 0, meaning that the red is 0, the green is 0, and the blue is 0. But white is 255, 255, and 255, meaning that the red is 255, the green is 255, and the blue is 255. Any combination of the RGB that has a value from between 0 to 255 can produce a color for you. So if you give like 100 to red, I don't know, like 200 to green, and 3 to blue, you will create a color and you will have the color. So this is how colors are understood in MATLAB with the R, G, and blue numbers, which is red, green, and blue. And these numbers have to be between 0 to 255. So the very first thing you need to do is that you need to activate your laptop camera, or if you have a USB camera connected to your computer. If you don't have the add-ons, when you create a MATLAB program, it will ask for it. So let's just first define, the very first thing you need to do in MATLAB is to clear CLC and close all to make sure that you are clearing the variable, cleaning the command window, and closing all the figures that had been opened previously, so you'll have a blank page. And then you need to define a folder, which is where you want to save all your images. So I was actually creating a folder and practicing what I want to tell you. So I have a folder path. I have created a folder path. So just create a folder path where you want your figures, your images to be saved. So that's the folder path that I want my images to be saved. And the other thing is that, for example, if you have multiple cameras, in my project I have 2 cameras because I want to see different things and analyze different things. So one thing you can do is that you can type cam list and just say webcam list. So what this does basically is that MATLAB is going to look at all the USB connections and all the cameras that you have, for example, your laptop camera, and it's going to detect them and understand how many cameras are actually there. So if you have multiple camera and you want a specific camera to do a specific kind of image processing, then you can say that I want my webcam number 1 to be active here. So meaning that open webcam number 1 and then start taking pictures as we're going to go through. So if you have multiple cameras, you just have to figure out which camera is which and then assign that camera to your MATLAB program. If you just run this program as right now, you might see an error like this, that MATLAB support package for USB webcams has not been installed. Open Add-ons Explorer to install the webcam support package. So if you don't have the support package for camera as an add-on to your MATLAB program, this error can happen. So all you have to do is just to click on here, on this link here, and it will take you to a page where you just log in with your MATLAB account, which is your Clemson username, ID, and your Clemson password, probably. And I don't know how you created the account. And then you can add that to your MATLAB. If this works, it's fine. But if it doesn't, there's another add-on that you might need to install. For me, this one specifically worked, but I was looking online and I saw some people had some problem, and the suggestion was to install this add-on also. So just install the first one and see if it works or not. If it doesn't, install the other one too. So yeah, Right now, if I do this, I will see no error because I've already installed the add-ons. So let's do this. Let's do something simple. Let's say that, okay, now take uh, a snapshot of my cam. So I have defined a cam here, and I'm saying, so I open my webcam and I assigned a variable named cam to my webcam, and I'm saying taking a snapshot of my variable cam and call this my image, for example. Call this my image, and then you can have a semicolon here too, and I'm gonna save it as imp1. Then you have to save it. Oh, okay. Okay. Okay, so I'm gonna save it with a different name. In class, because that's what I'm making in the class. Okay, so now if I take a picture with my camera, you're gonna see me. So this is done. Now we have created a path here, but we haven't saved anything yet. But we have our image, and our image is this. So if you want to see your image, you can always say show my image, and then you can just type it in your command window if you just want to test. So usually you write a program in the editor, and if you want to every once in a while check if the program is working fine, you can write the command in the command window and just check something. And here you can see me, and so it's just I basically just check to see if the camera detects get an image of me, which it did. So far you have learned how to detect a webcam with your MATLAB and then take a picture or a snapshot of your picture. But that's not enough. You need to save that picture. So for example, say you want to take multiple pictures every several seconds or what. I'm just showing you this in MATLAB, but in the LabView program, if you want to take multiple pictures, then that's a for loop and a while loop that you can add. You don't have to have the basically the clock here in the MATLAB program. You can just write one single MATLAB program that just takes one picture and analyze that one picture, and that's it. And then when you're going to LabView, you can put that MATLAB program in a for loop or in a while loop and say that, okay, do it as I said every 10 seconds or 5 times or whatever. But I just want to show you how you can save an image in MATLAB if you want to do it over and over again, because I think it will be useful. So for that reason, I'm going to have a for loop here, saying it's just like for from 1 to 5. From this many times, I want to take a picture. So I want to take a picture 5 times. That's why I put it inside a for loop. And I will say, open me a figure handle. Because every time that it's taking a picture, I want to open a new figure or a new figure handle so that I can compare side to side if you want to. But if you don't want to, you can just skip that. And then say, okay, after you have opened the figure handle for me, then image the image that is taken, or basically show, or basically show me the snapshot. So this, so far, get a snapshot, open a new window as a figure, and then image it for you. And then next thing is for you to give a name to that image, right? You want to assign a name to that image. And I can say, for example, base file name. I want to have the base file name as, so this what I'm saying here is actually going to show you how to keep adding to your image. So you say sprintf, that's a function in MATLAB. If you want to, you can search it and read more. Say I want to give an image a name like this. I want it to be a PNG, and I want my image to be image number 1, image number 2, image number 3. So this image will stay here, and that's kind of like concatenated string if you remember from LabView. So it's just adding the string together. So it's coming, because it's a for loop, it comes here, it will give the image name as image, and it will keep this hashtag or a number here, and this percentage of D is basically sorry, this percentage of D is basically reading from the K here. So it will read K first, and if K is 1, it will give this 1. If K is 2, it will give this as 2, and so on. But this is because this is an integer, we'll just type percentage of D here. So this way you can keep saving all your figures without re-saving on them, and then just have them all side by side. So this is how you will save. This is how you actually give a name to your pictures, to your to the pictures that your camera took. And now if you want to give it a name, or actually now if you want to save it, because so far you just gave a name to it, now you want to save it, you will say, okay, so this is the variable, and I want to have this full file, and this is my full file, my folder path and my base file name. So this is what happens. It will take a snapshot, your webcam will take a snapshot of whatever that you have. It will put it into a figure or in a window, and you can see it. And then you will give it a name based on the name that you want here, like based on how many pictures you're taking. And then you're giving a full file name as, okay, so my file name is this path plus this name. So it's going to combine them into one. And after you have this whole thing, you will say now save as. So what do you want to save as? I want to save as my handle edge, which is basically my image. Where do you want to save it? In the full file name. So this is how this is gonna work. And then if I add an end to it, and if I save it, now if I run it, you will see 5 images that it's gonna take I'm gonna take with my camera, and these 5 images are gonna get saved in this folder path with these names. So I'm gonna clean the folder paths that I have. So everything is clean here. Okay. Now I have a red keychain, and I will put a white background paper in front of the camera because I want to do image processing on that, and then I will just show you how this program file will save the images, and then we'll go to the next part, which is image processing. So let's run this now. Okay, so you can see that we have like 5 different images here, and they are all out of my keychain with a white background. So because I have type H equals to figures, every time I'm opening a new figure, so I will not rewrite on my figure, so I can see all of them. And if you see this path, you can see that the images, they are all saved here too, with image number 1, image number 2, 3, 4, 5, and these are the names. So I have the name for them also. So this is perfect. Now that the picture is saved, let's say that we want to do image processing on it. Let's say that I want to make the white background black, and I just want to keep the red pixels here, and I want to see what percentage of this picture is black, so that the rest will be like red. And this is like for image processing. So if you want to do some image processing, you kind of, for this method that I'm going to teach you, you kind of like need to have some significant color changes. You cannot have like different shades of red that are really similar. So you need to give enough contrast so MATLAB can really, process that. If you want to go like really deep inside, there are a ton of videos online that you can read. But for this specific class and video, I just want to show you like it's basically some introduction to image processing. So there's a whole class of image processing that can be taken, but I think that this will be a really good start for you to see how you can work with image processing and how many cool like features it has. So okay, now that you have this, let's go to the apps and then open this, and there's like image processing and computer vision section. Open the color threshold. Once you have opened it, click in here and choose the image from file. So you want to load your image. And I don't know, like load one of your images. I like this one because the color is better, like the lighting was better at the time. And then open this. Once this is open, click on the LAB part, and then you will see like this 3 LA and B. You will see the combination of the colors, and you will see the really like red colors and kind of like grayish and white. And then you can play with these ranges, and you can basically clean some of the pixels here. I'll show you what I mean. Like if I start changing this part, you can see I can change some of the white pixels into black, and I'm basically like cleaning my image, and I like it this way. And then I'm having some like, see if I change this, I'm removing the red one, and you can see here also that the pixels are changing. So I'm not going to change this. I don't like that. Let's change like other. Okay, this is good like this already. Let's change the other one in here. Okay, this was nice. So I was able to remove the keychain here. And once you get to the point that you feel like, okay, I'm having a good contrast, I'm keeping my red pixels here, and you'll like it, and you can see how you remove the pixels in here which were unwanted. You can say click on export and say export function, and then this is a function that is created based on what you have just done here. So as I told you, every picture has a red, green, and blue. So basically with this LA and B, you have defined a threshold or a limit for red, green, and blue, and you're giving a number from between 0 to 255 to each one of them. So if you look at the function that is created here, so a function, I'm not sure, I don't think that I talk about functions in MATLAB, but functions are basically sub-programs in MATLAB. You can create a function in MATLAB and give a name to that function, which in here the name of the function is create mask. And that function does a specific kind of program inside of it, and then you can keep that function and put it in your main project in here without having to write the entire program. So this is what function does. And this specific function was created based on the add-ons, the image processing add-ons that the MATLAB has. So it makes your life easier. You don't have to do all the coding yourself. And basically what it says that it's defining a minimum and a maximum for the each channel, which is like your red, green, and blue, and then it's just going to tell you what range do you want, what range of pixel colors do you want to keep, and then that's what it does. So you don't have to write the code. This is like super easy, super simple. Doing this, like using this and then drag and defining the limit, you can create a function, and this is the function. But you have to save a function, and that whenever you are using MATLAB, you have to save a function in the same directory that your program is saved. So I will save this in the same directory where my program, which is this, is saved, and I'm just gonna give it a create mask name. The name of the function should be the same as what it is saved. So these two, create mask and create mask, they should be the same. Okay, so we have created a function, we have saved it in the same directory, and now we are ready for the next round. So far we have opened a camera with MATLAB, we have taken pictures, we have saved those pictures, and we have created a function that can analyze that picture, meaning that it can change the picture color and omit some of the picture colors. And why did I go with a black? Because black is the black, is zero red, zero green, and zero blue. The white paper that I had in the background is not pure white. It had some colors. You can never get pure white because of the lighting and all these things in the room, and you cannot get pure black. It might be really black to you, but it might be like 010 or like something like that, which might be really small numbers, but it's still not pure black. But using this image processing tool, I was able to actually make it like really black and exactly black as 000. And now whenever I analyze my image, I'm sure that those pixels are pure black and I can count those pixels. So that's why we did that. Let's get started. And here, let's continue in here. So far we have saved the image. Now if you want to analyze that image with the function create mask, you have to read your picture again, and then once the picture is read, then you can run a function on it, and the function can omit some of the pixels and make them pure black. So that's why we have to say I am read, meaning reading. What do you want to read? I want to read my full file name. So it's gonna read basically this, or which is basically my image. So this is gonna read that, but you have to give a variable to whatever it reads, and I'm gonna give it a variable of f, just some random number. And then I'm saying, okay, now that you have read the image and you know that that image is called f, let's analyze that image. So to do that, you have to basically call your function. And I'm actually calling my function. Just notice that the name should be exactly the way that it is here and it is saved. So I'm calling my function. Here you can see this function. This is how it works. This is the name of the function, and the function reads the image or your RGB, and what it does is that it's going to give you a black and white and an RGB information. So I say, okay, read my image. I will give it a name f. It doesn't have to be exactly the same names in here, just the function name should be the same. So I'm saying I'm calling the function, and I want my function to read my RGB image, and I want that to give me my black and white and then my RGB data. RGB data. So now what it does is that it will read the image, it will do the image processing on it, and it will give you the black and white information and red, green, and blue information. And what you want to do after that is that you want to see your image and see if it did the threshold imaging right. So whenever you want to see an image, you will say I am show. So you will say I am show my RGB image. So whenever you are having an image, you will see you will use an I am show to see your image. And then the image that is showing to you, you want to give that a name also, because for your future you want to crop that image. In the next step we want to crop that image, so we will give it a name too. And I'm gonna give it a modified RGB. So whatever we have saved images, we have saved an image, we have create a function to analyze and basically threshold that image with some colors that you want, and now you want to see that image, and this is modified, not mRGB. And let's run it one more time. And I think it's better that I stop this video after that and then continue with the next video. It's gonna get long. So let's start. I'm gonna take pictures. Undefined function here. Okay. There is an E here that I forgot to type. So that's what is important. It's really important to have the same name, exact same name as this. So there was an E that was missing. That was the error. Let's run it one more time. Okay. Oh, this is really cool. Because I'm basically opening a figure every time this for loop is running. These are not closing, so I'm having everything here. Actually, basically just having the thresholded one, because I did it once in here. It will open one figure and do two things on that figure. So that's why it opened and then changed it. But I have this saved. I have the saved images, this one in here too, so you can compare them side to side. For example, image number 2 and here figure number 2. So this was the figure, this was the real image, and this is like the threshold image basically, or the modified image. And then you can do the same thing and then save your image here, your modified image. So all you have to do is to copy and paste this part of the program, which is giving a name to it with a path, and then save it. But make sure that you are changing everything here. First of all, you have to change all the variables, because you don't want it to resave here. So I'm just giving it a 2 here, so I will have different variables. And then the image name should also be different, otherwise it will rewrite on your previous image. So I will say, I will call them a modified RGB image. And the other thing is to you don't want to save as the H, but here you want to save as your modified RGB image. So yeah, just fix everything in here, and I think it should be fine. Let's run it and see. Okay, so let's open the folder where they are saved, and then you can see that all the pictures are saved, and then the cropped pictures, they are also saved. Usually the first, what I've noticed is that the very first image that is saved, the lighting on it is different than the second and then the third. It's just usually darker. I don't know why. The very first image, if you're doing it several times in the for loop, the very first image is always darker. So what I figured was that for my finding a threshold, I'll just ignore the first image and basically upload the second image forward in the add-ons of the MATLAB for thresholding the colors, and then I will use that and create a function, not the very first image. But for this specific problem, I loaded the very first image. I suggest you to use the second image, and then third and so on, not the very first one. I don't know why the first image is always darker. So that's why when you look at this one, the first threshold looks nicer. But as you move forward, the other thresholds are a little bit, like you see a little bit more darker pixels here. Whereas if you use your second image to do this analysis, it would have been better. Although, the lighting's changed because my hand was moving and you can see like some pixels are getting more lighter, and that happens too. But if you have a fixed camera that things are not changing and the camera is always there, the lighting is always similar, it's not changing, you should be fine. And I'm fine with my own problem at work here. So I hope you found this useful. We will continue on this program, and for the next video I'm going to show you how to crop an image if you want to crop an image, and then how to count a specific number of pixel points. And then we will go to LabView. Till next video.